Industrial America depends on machinery that works efficiently and effectively. Metalworking machines, those that cut, grind, drill, lathe, mill, and tap metals, rely on a variety of metalworking fluids to reduce heat and friction. For many years, oil was used as a lubricant, although oil often meant smoke, slippery floors, foul odors, dirty working conditions, and the danger of fire. Although oil provided lubricity, it did little to reduce heat, which physically hindered high productivity. A little too much power and the cutting tool was ruined. So researchers began studying the cause of heat and how best to reduce it. They discovered that a tool removes metal much as a snowplow. It lifts and pushes. This deformation causes 75% of the heat that wears out tools. The generation of heat was found to be a function of the thickness of the metal being removed, known as the chip. If the chip could be made thinner by 1/2 while maintaining the same thickness of bite, the heat-generating area should also diminish. Watch how this chip is made thinner, not by changing the thickness of the bite, but by swiveling this line. It marks the plane along which the metal is being deformed or sheared, and makes a clearly defined angle with the surface being machined. This is called the shear angle. Reducing the friction here increases the shear angle, thereby thinning out the chip and reducing heat. Under a microscope, the chip flowing up the face of the tool appears rough. Its tiny projections collide with the equally rough peaks on the tool face. Depending on the horsepower at work, the pressure at any one of these tiny contact points can be 200,000 psi or more. This is friction. Because of the terrific pressures, no fluid film, oil, or water will get between these points of contact and stay there. As a result, these points of contact tend to weld, and they must be constantly sheared away. Much of the machine's energy is expended breaking these welds, and in the process, fragments of the tool face are torn out and lost. The face of the tool becomes dished, and wear out occurs. When enough of these bonded contacts occur in one area, they fail to shear, and chipped material piles up on the tool face and becomes what machinists know as build-up edge. Hundreds of times each second, they pass under the tool point and remain with the workpiece. This is almost the sole cause of poor finish. So inadequate cutting fluids can be said to cause 3 problems: wear out of the tool face, low shear angle, and poor finish caused by build-up edge. Lubeze metalworking fluids from ZEP result from much exhaustive research. They improve tool longevity and performance, reduce and dissipate heat, lubricate the interface between chip and tool, and help flush away chips. Now, watch what happens when a small amount of fluid is introduced. The shear angle rises, and the chip immediately becomes thinner. The build-up edge that causes poor finish is gone. How do these new products work? The Lubeze fluid harnesses heat and pressure to actually form a solid in the tiny spaces between the chip and tool. The chip and tool form bonds with this chemical solid rather than with each other. Now, instead of having to shear welded metal, the tool needs only to shear a chemical compound. The chip slides freely up the tool face. The resistant force of friction is clearly diminished. The shear angle is large. The chip is thin. Less heat is generated and the tool lasts longer. Work speeds can be increased and productivity enhanced. In addition to improving tool life and finish quality, ZEP Lubeze metalworking fluids have these additional qualities. They are non-irritating, non-staining, and odor-free, and they won't cause smoke or rust. Today's high-speed, high-productivity metalworking machines require top-quality metalworking fluids to assure long life and optimum efficiency. Lubeze metalworking fluids from ZEP are an ideal choice.